Okay, it's time for Advanced Normal Transfer, the second video on doing normal transfer with the data transfer modifier. We'll be looking at two major topics. For the first, we'll be trying to solve some of the transfer accuracy issues we identified in the first video. We found that proximity-based transfers suffered from the problem that a mesh that gives us the right shape was often the wrong shape to get an accurate transfer. And if we used topology mapping to avoid this, then we were stuck with our original topology and all of its problems. The solution to most of these problems is to use multiple copies of the mesh and multiple data transfers chained together. You can actually transfer any normals from one mesh to another, and then from that mesh to a third as many times as you want, and that goes for all custom normals. I'm only going to be showing normals transferred from objects here, but if you've done normal editing by some other method, that also works. For the second topic, we'll be getting into our options to add more details to our normals. And I'll warn you up front that they're pretty limited. There's a lot of things that nearly work, but not quite, or have some major downside. So mostly we'll be going through them to understand what's going on and prepare us for addressing those same issues in geometry nodes. The problems don't change, it's just that we'll have the tools to fix them, but we have to actually go through with doing that. So yeah, not the most satisfying topic there, but the first one is quite satisfying because we actually solve a bunch of our problems. So let's get into it. Let's revisit our nearest face interpolated setup. This one worked pretty well, but not as nicely as projected face. And the reason this has the issues it does is because of this big air gap between the source and destination meshes. The data transfer modifier doesn't really give us any tools to help with this either. It's just for a given face on the destination mesh, it's going to pull its normal from the nearest face on the source mesh. It's like for this face, which is the nearest? Is it that one or that one? You know, there's like 4 of these it could be, and I'm not really sure which it is. We could probably figure it out. But it means we're not going to have a really clean mapping, and that's part of why we have these visible edges that we don't get with projection mode, because it doesn't have these problems. So to solve those problems, we really want to eliminate this air gap. I'm going to enable a shrink wrap modifier and also some of these shape keys so that I don't have, the ear causing problems. And also let's turn on this smooth. So now we have stuck our mesh to the face, and now there's not going to be any air gap, but our normal transfer is gone. Now, the data transfer modifier is still on, and we don't have an error message, at least not here, but what we're dealing with is a dependency graph update issue, specifically a dependency cycle. If I tab into edit mode, it's fixed because that caused it to refresh. If I open up the system console, you can see we're getting spammed with various issues. It thinks there might be a dependency cycle, and then I have a lot of actual dependency cycle errors up here, which are from other parts of this setup. Okay, so what's a dependency cycle? It's normally an issue that comes up in rigging, and it's when Blender doesn't know what order to resolve things in properly. Blender keeps a huge graph called the dependency graph, which tells it what order to run all the modifiers in. Here's a quick example of a dependency cycle in rigging. We have 2 bones. This bone is the child of this bone, so anything that happens to this bone happens to the child. And now I'm going to give this bone a copy location constraint onto its own child. And when I start moving it, it's just flying away. Like, I'm not doing that. Away it goes. And that's because it's copying the location of something that's copying its own location, that's copying its own location. We've created a cycle. And if I turn that off, it goes away. And if we look in our console, it really doesn't like that. So, okay, we're just not allowed to do that. But this is interesting. So I just saved the file. You can see my save. And now, if I move this bone around, nothing's happened. But I'm going to go into edit mode on the bone and come out again. And it's reporting the dependency cycle again for the disabled copy location. So its dependency cycle detection is picking this up even though this constraint isn't being used. Of course, if I delete it and save again, we can see it's not reporting it anymore, but it is reporting issues with this setup. reading the errors will give us an idea of what the problem is. We can see it's complaining about data transfer modifier and shrink wrap modifier, and the name of our objects is in here. So the cycle it thinks it's found is this, the normal shrink mesh depends on the head via shrink wrap, and then the head depends on it via data transfer. So they're both getting information from each other. It's a circle. But it's not a circle that actually matters because they're different types of data that don't conflict with each other. I don't fully understand the details of how it detects dependency cycles because it often picks them up where they don't really exist, because it's only checking on an object level, not a data level. And these objects technically are in a dependency cycle, just not with data that it matters for at all. Okay, so we just have to get rid of the shrink wrap. I've already got it applied as a shape key, so I'll just use that and delete the modifier. And now our problems are solved. Nope, we still have errors. And that's actually just because I have a copy of this object here, which also has the shrink wrap, so let's delete that too. And it immediately updated the normal, as you may have noticed. And now, no errors. So finally, things are behaving as they should. So that was an annoying but necessary interlude, but now we can get back to actually working with our shape. So we eliminated the air gap by shrink wrapping it to the face, and that looks quite good actually. If we toggle that shape key, we can see it's just making a huge difference. Like, just look at that. Jagged as hell, and now it's just clean. But of course, doing this has cost us our ability to change the shape, because, well, part of the point of this is we want to be able to change things. But if we start changing the shape, then we just bring the air gap back. So we need our old shape, but with the mesh in this position. And that's what we can get from chaining data transfers. We'll do our topology transfer to the copy of the sphere that still has the original shape, and problem is solved. And we didn't bring back our bad problems. So if we take this off wireframe and actually look at it, and I'll enable the smooth here. Beautiful. And of course, if we put subsurf on, then everything cleans up really nicely. We can use this training method for any combination, really. So this time we've got projected face interpolated and a copy of the head. So this is getting it from the sphere, and this is getting it from the copy via topology. And I'll turn that off, and let's shrink wrap the face to the source. So this is like our cast modifier. But unlike our cast modifier, we can go in and make whatever changes we want to our source mesh, and it's going to keep shrink wrapping to them. So we could try to alter the shape of this in whatever way we wanted. Now, right now, it's kind of dirty because we have topology issues, because this is still the head's topology. But if we turn this data transfer back on to project from the source mesh properly, then it cleans up a lot of the issues. It's still not quite perfectly clean, so the topology is still causing us some problems. I think the nearest face interpolated from the previous example was actually cleaner, but I'm not sure exactly why. And we can keep going. We can chain basically as many data transfers as we want. So this time this is going here by topology, then this to here by projected, then this to here. And we're going to take this head and use that cast modifier to turn it into a clean sphere. And then also the same thing on here, cast modifier, and they're exactly the same size because you can specify a size in the cast modifier and it will cast to that size. So they're in the same place, they're the same size. Perfect transfer by either projected or by nearest face interpolated. And let's not forget to check in on how our rig is doing. I've disabled the armature on the versions being cast, and I'll set this one back to 0 and hide it. And if we open the mouth, notice that the normals are changing on the cast versions, but they're not actually deforming because, well, they're not rigged. So they're getting normals from the deformed sphere, but they don't need to deform themselves. They can still fulfill their purpose of providing, I guess, a middleman to cleanly transfer the normals. Let's also check in on what this transfer chaining can mean for adding details. Here's a copy of our second setup. I've done nearest face interpolated, but if we do projected face, it's identical. So we got those working exactly the same. And I've added another middleman copy of the head here. Hide these. And we've got a displace modifier after the data transfer, and right now it's going to an empty vertex group. I'm going to go into weight paint and make sure I'm on that vertex group, which I've called displace minus, and on draw, and let's get an add brush with weak strength. And I'm going to grab, say, just a few faces here. Maybe a little more. And let's get some weight on those. And it is being displaced into this mesh. It's modifying the normals because of that, and then those normals are being transferred to our other mesh, which hasn't been changed at all. So not only can we chain our normal transfer modifiers, but we can make changes at each step along the way. Also made a nose. It's not too good, but 10 seconds of weight painting. So this method, it's only as good as your topology is. So if your topology is okay, then you can just do this. If it's like mine, where the nose wasn't great in the first place because I've got these quads and the shading needs to go, diagonal to the quads, then this isn't really going to help. The reason it's hard to get good results with, even if we turn up subsurf, is because we're dealing with a vertex group that's on the base form of the mesh, which isn't very high detail. And a lot of people watching this will actually be using faces that have even less loop count than mine here, generally for good reasons. Mine has, a lot because of the rig. So at the full subsurf level of 2, we're actually working with a lot of faces. If we could control our weight painting better on all of these, then maybe we could get a good result. But you see how the jackiness here reflects the original faces? It's actually cleaner on the original almost because of the way the interpolation works. And that's because the weight painting is also getting kind of interpolated by the subsurf. So if we applied subsurf and then made the vertex group, we might be able to get a better result, but we're not going to get a good result before subsurf. Now, we are dealing with the displace here, so we could use an image texture instead, and then we probably could get some nice results. I haven't made an example setup of that, but that should work. And of course, this method doesn't just have to be displace modifiers. You can use any sort of modifier that can go after a data transfer and after a subsurf. So you can do lattices, you can do surface or mesh deforms. You can't do hooks properly because they don't really work after subsurf for a variety of reasons. And of course, you can do stuff in geometry nodes if you have some other method there. You can't do shape keys, though, because a shape key is always before modifiers. This is also a good time to make a note about the different mix modes we can use. So far, we have only used replace. We also have mix, which looks a bit different, and add, subtract, and multiply. Now, actually, if you read the documentation for data transfer, it will tell you that add, subtract, and multiply aren't supported for custom normals. They do work. There's nothing wrong with them. It's just that the math they do isn't very useful for normals. I'll show you the problem. Let's aim our data transfer back at the original. And we have a second data transfer now that is the detail mesh on add. And it is bringing in the details, but they look a bit different. And that is because adding is adding. It's just not really something you want to do. You don't normally add normals together in a way like this. There's lots of math we can do to combine normals in different ways, but just adding or subtracting or multiplying them is not really one of the useful ones. And that mix mode, it's actually just adding. So replace already is mixed for normals. You have a factor between two things. So for whatever reason, when you do mix, it's just giving you the same behavior as add. So what options do we have for adding new details to the mesh that aren't based on the original topology? We've got a couple, and we're going to go through some of them and understand the issues. For this setup, we have our trusty sphere, and it's being transferred here to get a good transfer to the head. And then we have our nose decal, and it's transferring to this copy of it that's been snapped to the face. And we have two data transfer modifiers, one for the sphere. And if we turn on our details, hey, that looks pretty good, right? Until we get here. We've got a couple different problems. First, we have this big area that's like cut out of the shading, and that's happening because we're using projected. And you may remember from the previous video that projected only affects faces that line up with it normal-wise. So all these faces, when you project from the normals, they aren't hitting it. So the ones under it are getting its normals instead of the sphere. And if we switched it to nearest face interpolated, then all of the rest of the mesh that isn't under it will still get the value of whatever face is closest, which is probably these outer edges. So that's no good because it wipes out our sphere normals. We can get it to not behave like this by using the max distance checkbox under topology mapping. This lets us set a distance check. And this is in Blender units, so we have to go to a pretty small number. And I actually forgot to mention this in our previous video, but that was because it's basically never useful for normal transfer, although I presume it's useful for some other things. Because if we set it low enough to to give us the same behavior we already had, then it can mess up other areas. And it's hard to find a value that is right for getting the right behavior without causing more problems. As soon as you start deforming things too, then even if you find a value that's good for a certain thing in a certain place, then you only have one value to work with. You can't set this to be like a vertex group or something. So I've about dialed that in to where it still picks up all the nose, but now we're just back where we started with projection, so why bother? We'll just keep using projection. The second problem is that all of the shadow edges we do have are just ridiculously jagged. Like, what's going on there? Was that there before? Well, a little bit. You can see that even the sphere is picking up some of them. And that's because these are just being caused by good old diagonal faces and interpolation. We can see if we go on optimal display that these are the faces that Subsurf is giving us. So we wouldn't have these problems if we were transferring to cleaner topology, but like this we do. So can we do anything about these problems? Well, one option to try to stop these margins is we've got a vertex group for the nose, and we can plug that into our nose modifier. And that reduces the margin problem, because now it's only transferring onto vertices that are on the interior of the nose. But the issue is not as solved as it may look at first glance. It happens to be solved for this particular shape, but we can actually see that there's something else going on here. This is a lower frequency of wiggliness than our saw edges on these. And that's because we are transferring the original nose shape to this mesh, and it just so happens that the original nose shape is fairly narrow. So if I turn this off and we get the broader shape from this wrapped mesh, we can see that we've got a pretty big problem still. So now we've got these wavy edges. Well, actually they're also jagged edges, but they've been smoothed by Subsurf. What we're looking at here is the edges of our vertex group that we weight painted. And that's because it is painted before the Subsurf. If we turn the Subsurf off, it's only as high quality as the original topology has vertices, and it also has all of the issues of being linearly interpolated across these faces. So the Subsurf smooths it out, but having a vertex group that is made before Subsurf and then smoothed is not the same as a vertex group that is after a subsurf at full quality. So far, we've been doing all of our transfer after subsurf, but in this case, we're gating it with something that is pre-subsurf and doesn't get interpolated into a smooth line. So again, we didn't see this problem before because it just so happened that the mask was actually larger than the shape we're transferring. If we switch to a smaller version of the mask, like this copy I've made, then first of all, the shape is even worse because we just don't have the vertices to define the mask properly. And also, we can start to see our subsurf saw blade coming back at the edges where the masked area is smaller. So the vertex masking can't really solve our main problem properly. So why do we even have these margins on this mesh decal in the first place? Could we just get rid of them? Well, they are there for a good reason. If we look at the original with its proper subsurf and smooth, we can see that we get a nice shading transition from this main loop here. We've got curvature down here being caused by the subsurf and smooth. If we deleted all those outer edges, it would be the same thing as if I mark this sharp and, remove the interpolation. We would instead have this like hard edge on our shading, which it goes past eventually, but it's not the right look. So we need this loop to define this curve, and then we need another loop outside it for proper interpolation, remember. And then this very outer loop we could probably delete, but it doesn't really address the problem because we still need those two. So we do have to deal with this, but maybe we could just get rid of it on this version and not on the original. I've got a shape key of all those loops slid inwards, and that does get rid of the problem, partly, but there's still this. It can't completely solve it, we just have even more horrible jaggedness. Some of that is the regular subsurf jaggedness, and then some of that is because any of these faces that still have even a single point cross under here, even on projected mode, they're going to get those normals. And it's a mess, partly because we have three faces kind of on top of each other now, like, there's a bunch going on, but we're always going to have this bad edge. So it's better if we leave this margin out and solve it a different way. And that different way is actually quite easy. We've got a vertex group on the nose destination mesh, and we've got a second normal transfer, and that normal transfer is coming from the sphere destination mesh. So that is enabled, and the nose is currently not contributing anything, because it just has the same normals as the sphere. So even though the nose is projecting to some of these faces, it's projecting the same thing. The second data transfer modifier that is transferring the original nose normals with topology is masked with that vertex group. So when we turn it back on, it's only affecting the interior of the nose. So this has solved our margin shelf problem again by just giving it the same normals. It still, of course, can't fix our subsurf problem. And I'll give you a small spoiler alert here, but nothing ever does fix this problem. We were okay before when we were just transferring from the sphere because it's a large shape that doesn't have any curvature. It doesn't have a change in curvature from here to here. But this does, so in any detail situation where you have a rapid change, a contrast across diagonals, you're always going to have this problem. You can turn up subsurf more, but that doesn't remove it, it just makes it smaller. Because the issue here is that we have a limited amount of vertices, and we have our linear interpolation issues. So you either have to have the right topology, so, parallel loops, like I said before, or you have to solve this in the shader, which we will get to. If we bake a texture of these normals, then we don't have this problem because then the limiting factor is the pixel resolution, not the vertex resolution, and it's not hard to have enough pixels to solve this. Or, of course, if we use a procedural texture. But suddenly, plot twist, the problem is completely gone. So I said it couldn't be fixed, right? Well, this isn't a fix, this is a workaround. You cannot fix that topology problem, but you can just get different topology. In the previous setups, the nose decal here was a wireframe, and we were looking through it and seeing the normals on the mesh. But now we're actually just looking at the mesh. I've just pasted it on here, and I'm transferring to the nose mesh instead, and of course it has the correct topology. So it's kind of a sneaky trick, and it won't always work because we've now got a mesh border at the edge here. We can move it around, of course. So I've got a couple of shrink wraps to keep it above the surface, because without these, you can end up with some Z fighting. Like there, the base head is sticking through it a bit. So I've got one shrink wrap on the edges to make sure they always will stick to the mesh very well, and others that make sure the interior of the nose will stay above the surface. The shrink wrap target is actually a hidden copy of the head, though, not the original head, so that we don't get a dependency cycle. And this is still using the same double transfer process as the previous setup to make sure the overall sphere normals are on those margins. So this is a great way to solve this problem when you can use it. The details of using it correctly are going to depend on your shader setup, of course. Depending on how you're doing line art, like if you're using freestyle, it'll pick up these border edges unless you exempt them. And there could be issues with your shader. If you're using something fancier than a toon shader, you may have to make some of the edges of the decal transparent in the shader or whatever. So you'll have to put in a bit more setup work to use this method, but it is very clean because you can just make sure your topology is completely optimized. You also have to watch out for rigging problems when using this method, since it's not going to match your original face. So if you're using it somewhere that needs a lot of deforms, like around the mouth or in the brow here, or if you have a crazy squash and stretch rig on the nose, like I do, then you're going to need to make sure it's compatible or that you have a modifier set up that's going to keep it properly wrapped on the surface. And that's going to have performance costs, and it may not look that great until you have everything turned on, so it can be finicky to work with, but it does give you the results you need. And of course, if you remember from the first video, this is another one of the things that we'll be automating in geometry nodes, which handles it way better than shrink wrap because we'll end up actually UV wrapping it on like a texture, which solves a bunch of these issues. Even though we already know what our winning setup is, there is one more I want to show because the problem with it is something that will come up later, and I've also seen people try to use it and then run into problems. So in this version, the nose and the sphere have been merged together into one mesh. So the problem with this method is that we just have so much less control because these objects are merged. We can't do topology transfers to them individually, and we've lost most of our ways that we can control what transfers to what. It's going to be nearest face interpolated or projected face interpolated, so we just have no method to tell it to have this face go to the sphere instead of the nose. In fact, I've pulled the sphere out here in order to not have weird distance issues. Like if I set this to be only half as much, we can see that now on the bridge of the nose, it's picking up the sphere as the nearest thing and interrupting the nose normals. So basically it's a depth detection issue, which we can get around if we cut out the area the nose is in so that there aren't two conflicting faces, and then do our other trick of transferring the clean sphere over the margins of the nose. But it just gets ridiculously convoluted because we have to merge meshes and then transfer stuff from other meshes. And so it works in the end, but it's just way more steps than the other methods we've looked at. So basically, we never want to have to do this. So we understand our detail setups pretty well now. So now we can move on to the next issue. Yay! And this is another issue that we can't fix until geometry nodes, but you need to know about it. So this is our nice mesh decal. We're transferring from here to here, and this is stuck on the front of the face and everything's nice. But what if this decal was not a nose? What if it was some other feature and it needed to wrap around the head or be on the side of the head? Let's simulate that by taking this nose, and I'm going to move it around the head. And it's going to get pretty mangled because it's just shrink wrapping to the surface. But we'll still be able to see the problem I want to show you, which is, even as we get around here, this should be fully shaded now. But it is not, because where this mesh is has nothing to do with the normals of the shading, because they're coming from here. Blender still thinks that these normals are pointing forward, because they're coming from here. Whereas if we change this, then that's going to transform them properly. So this is a problem of being stuck with our object space normals. The decal workflow we really want is to model something like this flat, and then have it wrap onto our head properly. We don't want to be in a situation where we have to make this match the proper shape. We could do it, and it's not the end of the world, it's just way less of a convenient workflow. Basically, we want to work with this like it's a flat normal map texture, but we're not in tangent space. Most normal maps we work with, those flat ones you're used to, they are tangent normal maps, and currently this is behaving like an object normal map. We'll spend a lot of time explaining and solving this problem later, as it's kind of the problem, but the simple explanation for now is that this is currently just setting these normals to a constant value. It has nothing to do with the sphere. We're literally using the sphere on the margins, but on the main nose shape, we're just mixing to that. We're overriding the sphere entirely. But what we really want is for this to be an offset on top of the sphere. We want it to be whatever the sphere normal is, and then bumped out on top of that into the nose shape. And that's what we need for basically all details on the face to work other than the nose, which is why I've been using the nose as an example and not anything else. So overall, it's not that it's impossible to do this workflow with just data transfer, it's just not very efficient, and it's going to get very tedious if you're working with a bunch of details, especially if they're in areas that deform. Because if you're transferring from an undeformed base shape like this to a destination mesh that is then deforming, then your shape isn't deformed properly. So then you have to rig these base shapes and then transfer to them, and it just all becomes a mess because of this issue that you're mixing to a constant as opposed to adding an offset or combining an offset in. So we could potentially spend a lot more time talking about ways to work around those issues, but we're not going to, because we're just going to move on to a more efficient way to handle all this. And speaking of efficiency, we now come to our final setup that we'll be learning about in this video. This is my favorite setup to work with. It puts together a lot of the different things we've learned, and it is the closest to the method we'll be using in geometry nodes. What we're looking at here is the same idea as our earlier setups, where we duplicated both objects and transformed them to be about the same shape, so that we could get a clean proximity transfer. But this time, that intermediary shape is flat, and it's actually the UV map. We can flip over here to UV edit mode, and there it is. That's the UV map. It's mirrored, of course. And the way this is made is with an add-on called Text Tools, which has this option to create a UV mesh. And what this is doing is duplicating the object, and it makes a shape key, and the shape key is where all the vertices of the mesh have been set to match their position in UV space instead of their original world space position. And of course, we can also do this with geometry nodes, but this is where I got the idea from. So using this sort of setup has a bunch of advantages. You've removed one of the three axes, so you just have way less problems to worry about. This means, first of all, that your transfers are generally going to be much more clean and accurate. Like here is a previous copy of the head where we have the shrink-wrapped source mesh, so this is getting normals from here. And if we compare the two, we can see that this is much more jagged. This is really clean in comparison, even though we have no subsurf on. Now, this is an advantage that doesn't always matter, like when we do have the subsurf, they're both going to be pretty clean. But it is indicative of how much cleaner the transfer is. It's also handy if you're using any sort of setup where you need to really get things lined up for a clean transfer, like the detailing stuff we were looking at earlier. We've just removed the whole element of having to get it onto the face properly and all the alignment issues that can cause. And of course, one of the biggest advantages that you may remember from the first video is that this just is our UV unwrap. So we can just match a camera to this and render, and that is our baked texture. It removes all the tedium of the regular texture baking workflow. Now, of course, the downside of this method is that it has a higher setup cost than other things we've looked at, which is part of why I didn't bring it up earlier. And that is that we need a clean UV unwrap in the first place. For this method to work, we have to have super clean UVs, and they have to be unwrapped into a box shape like this. And that may seem daunting because pretty much everybody hates UV unwrapping, and generally every part of it is miserable and all the tools are terrible. But actually, we've already learned a very convenient way to do it, which is to transfer it by all the same rules that we've been learning about so far. Because, as you may have noticed, down here with our custom normals is our UVs. We'll need to unwrap both the source and destination objects and then get them lined up properly. In this case, I only unwrapped the face part of the destination, but I unwrapped the entire source mesh. So we've got a bit of an alignment issue here, like where exactly do these line up? And is the scale even right? And actually, for this example setup, I only just eyeballed it. But for the proper setup, we'll make sure that they align perfectly. So I did originally plan to cover how to make one of these unwrapped UV mesh flat transfer setups and put it in this video, but this is already getting pretty long, and I think the whole UV transfer topic deserves its own video, so we're only going to take a quick look. Here is a new transfer mesh that will be used for both normals and UVs, and we can see that it's a nice clean shape, although it could use a few more points around the jaw, but it'll get those. And if we snap this back, it fits the face very well because it was made by just snapping a plane to the face and then making an even number of loops in it. It's 12 by 12, with plenty of margin over the area we're going to transfer to. Then if we check out its UVs, we can see they're very clean and evenly spaced. And on our material, here is our UV map. This is all messed up because its UVs are all over the place. And I've got a group here that mapped a grid to our UV space, so we can see how nice and clean those are. And now if we turn on transfer, we can see we get very nice clean UVs on the head itself. And this is a nearest face interpolated transfer, so it's following all the same rules as what we've learned about. So now if we applied this, we would have those super clean UVs on the head, and we can even move things around in the UV map and watch them move on the transfer object in real time. So super easy way to get UVs. We'll be looking at that more in the future. So while I was putting this setup together, I ran into a data transfer bug that you should know about. I was talking about how clean this setup is, but if you look here, that is not clean. There is some weird stuff going on. The rest is pretty much all clean, but there's problems down here, and there's some problems way up at the top of the head. If we look closely with optimal display off, we can see this is some sort of transfer issue, like accuracy issue, where it's going to the wrong face and then having interpolation problems. Like if we shade this flat, then you can definitely see that essentially it's getting the wrong triangle, the wrong face corner. I've seen this happen on multiple setups before. This is the first time I've seen it happen on one of these flat setups, so I don't know if it's really a feature of these. I think this is just a general data transfer bug. Part of how we know it's an issue with the transfer from this to this is that the problem doesn't exist on this mesh. We can see that it's transferring from here to here and keeping the problem, but if we make another normal transfer modifier aimed at our old shrink wrap, and this is aimed at this, then no problem. So it's not being inherited from here, it's happening between here and here. So this is annoying, but it is not a showstopper for us because there are a couple ways around it. First of all, it doesn't happen when we're transferring with geometry nodes, which is what we're going to do anyway. I'm going to switch the material over to getting normals from geo nodes, and it goes away. No problems. So that's one thing. I've actually done a bunch of tests transferring things other than normals, and it doesn't show up in any of the other ones. So I think something is going wrong in the actual custom normals pipeline, which is what Autosmooth enables. I'm not sure what. I've tried all sorts of different settings and basically everything I could think of, and nothing addresses it except geonodes, or for some reason, if we rotate everything by subsurface, if we rotate everything by 90 degrees, then the problem goes away completely. So it's something funky in the data transfers math that isn't causing problems in other areas. And it's annoying to have to rotate this by 90 degrees, but it's not doing any harm. And yep, clean on our main mesh too. So that's some sort of bug. I'm going to try to narrow it down a bit more and report it. So by the time you're watching this, it may already be fixed. But just keep an eye out for that in your own setups, whatever they might be. So I think we're about done talking about the data transfer modifier. There was some more stuff I thought to put in, but, well, you kind of get the idea that there's a lot of things that nearly work, but none of it quite works. So let's just move on to the fun part and get into geometry nodes in the next video and leave all these problems behind. And of course, remember to like and subscribe, and you can support me on Patreon. Thanks, and I'll see you next video.